Dear colleagues, we present to your attention a report, Development of the Modeling System Core for Severe Plastic Deformation Processes. The processes of severe plastic deformation make it possible to obtain materials with a fine-grained structure and improved physical and mechanical properties. Their research and implementation in industry are more difficult than classical processes of metal forming. Currently, various CAD systems have been developed for the design of individual processes or groups of typical processes of metal forming, which allows to reduce the time for preparing the calculation in the KI system. For less common SPD processes, such CAD doesn't exist. When simulating SPD processes, additional problems arise related to the features of the process itself. The need to simulate various variants of billet loading schemes, large plastic deformations, changes in deformation routine, thermal mold, etc. Nowadays, the problems of computational complexity in modeling plastic deformation processes, which are labor-intensive and require significant expenditure of machine time, remain unsolved. The purpose of this research is improve the quality of integration of CAD-KI systems and develop the functionality of integrated automated modeling system based on the creation of an object-oriented core for combining external independent models that provide flexible and adequate modeling of multi-stage SPD processes using parametric models. To solve several tasks in the design of SPD processes and the development of AMS functionality, it is necessary to develop a core that should provide the possibility of modeling multi-stage combined SPD processes, support the integration of external models. This modern CAD system, SolidWorks, for example, and KI, Abacus, Qform, for example, for modeling stress-strain state of billet during deformation, to provide research into the technological possibilities of new SPD processes based on the parameterization of models of billets and die sets. Based on the analysis of the capabilities of CAD-KI systems, we have highlighted the functions that should support the core of integrated AMS and the necessary mechanisms for this. They are represented in this slide. The class diagram of the integrated AMS core is shown in this figure, which presents the connections between classes of the core, which provides integration with functional models of the design system. An important issue in conducting research is the planning of experiments. To plan experiments on the modeling of SPD processes, it is necessary to create a list of objects that contain variant of task, for example, several billets with different sizes, parametric model of equipment, etc. Then, to study a specific technological process, a sequence of work with various models is established. These models are selected from the general list. This list subject to change. A display of pre-created list of workpiece and equipment is provided. To simulate the selected technological process, the model is automatically built for the Abacus KI system. The modeling module launches each model from the experiment plan to perform calculations. The import of simulation results is implemented in the analysis model. A Python script is used to connect to the Abacus post processor. The researcher could choose the values he needs for future analysis of the technological process. As a result of the simulation cycle, one of the technological process options is selected. The interface of the geometry module displays the parametric model of the selected technological process and allows you to make changes to the dimensions. Clicking on the Transfer to CAD button leads to the transfer of a 3D geometric model to the SolidWorks CAD system. Interaction with SolidWorks CAD is implemented using the SolidWorks API. So, our research is focused on the development of the structure of the core of the integrated automated modeling system. The AMS ensures an increase in the functionality of the CAD and KI systems by combining them with several external independent models. The AMS modeling technological schemes of several plastic deformation processes, the behavior of materials in deformation processes, and reducing the cost of choosing the scheme and parameters of the deformation processes. Object-oriented software was developed to analyze the influence of different initial shapes of the billets and the die sets on the changes in the billet's cross-section during deformation. This software is written in C# using the WPF interface and the page structure of the main application window. Using parametric models of processes enables automated calculations in KI systems and the generation of 3D geometric models of die sets in CAD systems. The design of experiments allows automation research of several plastic deformation processes and reduce the cost of studies. Important and accumulating calculation results in the KI system made it possible to find the optimal values of the parameters of SPD technological processes. The parameter of the deformation models obtained based on modeling are the basis for constructing the geometry of the die set in CAD with subsequent integration with KI to calculate the stress-strain state in the volume of the billet. Ways to expand software functions to support various SPD processes are proposed. Thank you for your attention.